Now, let's take a closer look at what happens at each of the steps of Aries, starting from the analysis phase. The analysis phase performs three main tasks. First, it decides the starting point in the log that the redo phase should start from. Second, it goes through the logs and figures out which pages in the buffer pool were dirty at the time of the crash. It adds them to the dirty page table. Third, it finds out which transactions were active at the time of the crash and were aborted by the crash, and therefore should be undone. To be able to do this, the analysis state starts from the most recent checkpoint. Remember, we said that a fuzzy checkpoint is reliable only up to the point of the earliest log sequence number it has recorded. Therefore, analysis starts from the begin checkpoint of the most recent checkpoint. It initializes the dirty page table and the transaction table to their values within the checkpoint. Then it starts analyzing the log from that time going forward towards the time of the crash. If a transaction has an end log, it removes it from the list of transactions. If a transaction has any log other than the end log, it adds the entry to the transaction table and sets the last LSN to the log sequence number of this log record, because it is the most recent log for that transaction. If the transaction is a commit transaction, it is marked to show that there is no need for undoing it. Otherwise, it is marked for undo phase. If the transaction is a redoable transaction that affects a page which is not yet recorded as a dirty page, it adds the page to the dirty pages and sets the pointer of the dirty page table entry to the log sequence number of the current record. By the end of these steps, the transaction table includes the list of all active transactions at the time of the crash, and the dirty table includes all dirty pages at the time of the crash. We are now ready to proceed with the redo phase. During the redo phase, Aries applies all of the updates from all of the transactions. It also performs the CLR log actions, which are the logs that indicate the undo transaction logs. In simple words, Aries redo is a full repeat of the history as it is written in the log. Redo pass performs this starting from the smallest log sequence number that has a pointer from the dirty page table. It finishes this at the end of the log sequence. For each redoable log record, it performs the action described in the log record, sets the page LSN, which is the log sequence number causing an update on that page, to LSN of the redone record. While doing this, redo does not produce a log of its own. The redo is performed for all update or CLR records unless one of three conditions happen. First, if the affected page is not in the dirty page table. Second, if the affected page in the dirty page table has a pointer to a log with a larger log sequence number that the current log record shows. And third, if the page LSN of the dirty page is larger than or equal to the LSN of the examined log record. Note that all of these conditions show that the changes to this page are already written to the disk. Therefore, it means that there is no need to do it. The undo phase begins with the transaction table. Transaction table includes the transactions that were active at the time of the crash. These transactions are called loser transactions because they are aborted and should be rolled back. The actions of loser transactions are undone in the reverse of the order they appear in the log. Remember that last LSN was the pointer from an entry in the transaction table to the most recent log record for that transaction. To perform the undo, Aries repeatedly chooses the largest LSN value in the set of loser transactions for processing until the set is empty. To process a log record, if the record is an update record, it is undone and the corresponding CLR record is written for the undo action. And the previous LSN, which points to the previous record for that transaction, is added to the set of logs to undo. If the record is a CLR record, it means it is a log record for an undo action. Remember, we said we do not undo an undo. So, if the transaction is a CLR, it does not need an undo. In a CLR record, undo next LSN is a field containing the LSN of the next log record to be undone for the corresponding transaction. Therefore, if there is a value in the undo next LSN of this record, we add it to the undo list. Otherwise, if the undo next LSN is null, it means the end of the undo for transaction is reached. In this case, an end record is written for that transaction. When the undo set is empty, the algorithm is finished. What happens to a database management system if it crashes again after a crash while it was recovering? Let's break the question down and answer it for each of the Aries phases. What does the database management system do if it crashes during recovery if the crash happens in the analysis phase? Basically, nothing. It will just run recovery again. What if the database management system crashes during the redo phase? Again, nothing. It starts from the beginning, performs analysis, and performs redo again. Some transactions that were redone in the previous time and their result were written on the disk because of redo will not be redone again because of at least one of the three conditions that shows the result is already on the disk. Now, what if another crash happens when the database management system is in the undo phase? The nature of the compensating log records, the CLRs, ensures that an undo is not applied twice and keeps the correctness of the system. For example, in the shown log, after the first crash, the actions for T2 and T3 are undone, and the last CLR log shows that T3 is completely undone and marked as ended. Therefore, when the system is restarted after the second crash, the only active transaction is detected to be T2. The system will proceed with only undoing the actions of T2.